after graduate from school, I first worked for Brookhaven National Laboratory at Long Island as a famous DOE laboratory. I was a nuclear expert working on the nuclear energy sector and doing research for nuclear safety and on the nuclear energy for 12 years at Brookhaven Lab. And about 2000, early 2000, and I was an expert, by the way, for nuclear risk assessment, doing PRA work called the probabilistic risk assessment. So I was top expert on the PRA, working for NRC, U.S. Nuclear Regulatory Commission. So I had a chance, had a phone call back in early 2000. Somebody called my office and said, hey, we know you're an expert on PRA, probabilistic risk assessment. Because, and then the call is from NASA, and we are building a team trying to look for a need to assessing the space shuttle risk and try to build a model and try to assess in the system level risk of space shuttle. So NASA had a number of major accidents at the time, and of course Challenger explosion was one of them. And after that, they wanted to, NASA had a policy utilizing more of the PRA technology, which was advanced very extensively in the nuclear industry and the national laboratory. So I was expert on that. So they invited me to come to work for NASA. That's how I decided to move to Houston in the year 2000 and to lead a group of people, a team called the Space Shuttle Risk Assessment PRA team. So I was a lead engineering expert, building a team and laid out the model and trying to come up with the mathematical model to assessing how risk in every single system in the whole system of space shuttle called STS, Space Transportation System for NASA. So ever since I worked there, since 2000, year 2000, and at late 2005, I'm sorry, I got a call from NASA Goddard Space Flight Center asking me if I want to work there, looking for someone with my expertise to head up a team to managing the risk of NASA Goddard Space Flight Center, because at the time, remember, late 2005, NASA is doing the Constellation program going back to the moon under President George W. Bush at the time. So NASA Goddard was doing called ARO, Lunar Reconnaissance Orbiter Program. So if U.S. want to send human being back to the moon, you have to first do the lunar reconnaissance project. So have to send a satellite going around orbiting the moon to remapping in the surface of the moon. So that's why I got this opportunity to transfer to NASA Goddard. So I was the head of the risk management for the whole NASA Goddard Space Flight Center, working closely with the manager, with the project manager, working on a number of major projects like ARO and also JWST. That's the next generation space telescope, sort of replaced the most current Hubble Space Telescope. So I worked there for almost 4 years because I was so passionate about energy from space. Remember 2007, 2008 time period and oil gas, the gas price hit the roof, and I remember paying like over $4 per gallon. That really struck me because I've always a believer of solar energy. It's the most reliable, clean energy form of energy for humanity. So I've been writing a lot of papers, published articles about how human society should really focus their attention not digging under the ground, but looking upward, look at the sky, looking for answer from the energy of the sun. So I very much believe that we have a very good potential to develop and launch a solar power satellite and launch the solar power satellite into Earth's orbit, so we can collect in the energy of the sun 24/7. Not only it's proven technology, and satellite all the communication satellites have been supported by the energy of the sun, and we have solar arrays on every single satellite, space vehicles. That's how the space vehicles satellites getting their power directly from the sun. So basically, it's a proven technology, and we've been utilizing this technology for the last more than half a century, to supply power to all the communication satellites and space vehicles, including ISS, the International Space Station. You see all those solar arrays sticking out. That's where they're collecting the energy of the sun. So all we need to do is somehow collecting that energy of the sun, scale up the solar power satellite. So in other words, instead of collecting power at the hundreds of kilowatt level, we want to be able to collect the energy from the sun at the megawatt scale or gigawatt scale, so we can actually converting that energy into some form of radio wave, for example, microwave or laser beam, and we can transfer that energy to the surface of the Earth. So we have a 24/7 supply of energy, and for base load electricity consumption on Earth. And of course, there's a zero greenhouse gas emission. So that's how I was so passionate to get involved supporting this project. And I was a senior fellow at ADWIC, or called the ATWG, organization called the Aerospace Technology Working Group. It was organized by a group of NASA experts back in the 1970s. Basically, people get together from time to time, every few months, every year, to discuss all the most advanced concept of space project and what we can do, what human being can achieve in terms of utilizing in the space, the resources in space, not just doing things on Earth. So that's how I decided to, because at the time I was part of the NASA demonstration team, solar power demonstration, during the time of 2008. But due to funding, at the time NASA was focusing only going back to the moon, the Constellation program. So I thought maybe it's time for me to better spend my time and energy to work with the private company, so they can, because we don't get the kind of government support we're expecting. So I said maybe I can better spend my energy and time to supporting the private company to try to raise funding from the private sector, so we can help design and build a demonstrator, a solar power satellite demonstrator, so we can actually not just approving the concept, but we were actually doing a pilot project and do a small-scale solar power satellite and launch it in Earth's orbit, actually collecting the energy of the sun, beam it back to Earth, and use the ground station to collect the power that sent back from space and convert it to the terrestrial energy and connect it to the power grid. So that's how I decided to do 2 years ago, and then I joined the Space Energy Group, and I've been doing that ever since.